Here at Thomson, we're continuing to see a strong and exponential trend towards linear actuators in motion control applications. This change has not been quick though. For decades, other technologies, despite their drawbacks with control and safety, have been the go-to choice for heavy-duty application due to their load handling capabilities. Today, electric actuators not only match the high power of their competitors, but they offer a number of smart, eco-friendly features that help usher it towards next generation of linear actuation. Traditionally, you would see fluid power systems like hydraulics and pneumatics found in applications that require a lot of muscle. However, that comes with a lot of drawbacks and costs. Designers and end users have to deal with a number of different intrinsic flaws in those systems. Hydraulic systems can be unnecessarily complex when you consider the number of different components that add into each axis. Now, while one system can contain a reservoir, pump, system of hoses, screens, filters, valves, adding in a new axis causes the user to consider adding those additional components each time. As you can imagine, when you have so many different systems working together in one axis, there is an above-average risk of failure. And with machine designs getting smaller and smaller, these space-consuming systems become more burdensome. Additionally, there's distracting noise, energy consumption, and their associated costs to consider. Safety is yet another concern when considering hydraulic systems, because they use fluid to handle their motion back and forth. The short list of issues with this fluid include toxicity, contamination, slip and fall risk, burn hazards, as well as cleanup and combustibility. That's not to mention the environmental impact as well. Electrification with linear actuators provides an alternative solution to all of these problems and adds many benefits that other competing technologies cannot. For starters, all of its functionality is built into its compact housing, which provides a large savings in space, as well as adds flexibility to its design. The actuator is only connected with a few wires as opposed to the complex hydraulic system seen here. Additionally, there's no fluids to leak or contaminate the environment. There's little to no noise, and it's maintenance-free. Costs over the life of the system are another key benefit of electrification. Due to the longer component life of the actuator, its high redundancy, as well as battery operation, which leads to low energy consumption, users can expect a significant savings over hydraulics throughout their life cycle. A feature set that puts electric actuators into a class of their own is the advanced control and diagnostic suite integrated into the PCB of the design. Onboard digital and analog components allow machine designers and users to communicate with other machines in their network through use of low-level switching technology, speed and force feedback, as well as position control. Plus, users can utilize our CAN bus technology for diagnostics and condition monitoring functionality. What's really exciting about electrification, though, is our most recent actuator advancements. As I mentioned before, power is one area where we have conceded to hydraulics. Now, with models such as Thomson's Electrak XT, these electric linear actuator designs can handle larger loads, up to 32 kilonewtons, as well as strokes up to 1200 millimeters. They travel at up to 75 millimeters per second, can handle duty cycles up to 100%, and have increased life expectancy, up to 275,000 cycles. In situations where the actuator finds itself stuck, broken, or in an awkward position, a machine builder or user can manually move the actuator utilizing its manual override functionality. The user can utilize one of two features, the manual brake release or the manual override. The manual brake release releases the load-holding brake on the actuator and allows gravity to assist the load into its desired position. With the manual override, the user can fully extend or retract the actuator one full cycle with no power. These two features are handy for machine maintenance and installation. Electric actuators have also caught up to hydraulics when it comes to shock load handling through a dampening feature that's integrated into the rear adapter. This opens up the actuator to a number of new possibilities in application. Last but not least, the actuators are designed to withstand the harshest environments and ingress conditions. All of these benefits continue to further the trend towards electrification for motion control designers. Thomson is at the forefront with a simple, clean, and powerful actuator offering advanced controllability and safety features. To learn more about the benefits of converting to electric, you can visit the Thomson website. There, you'll have access to a number of resources, including an actuator selector tool, interactive 3D models, videos, webinar recordings, technical articles, and more.